Okay, this question is what's known as a reacting mass question. It's giving you information about one substance, it's giving you a balanced equation, which is here, which we need to use in the question, and it's asking for information about another substance. So in part A, for example, we're given this equation to show sulfur reacting with oxygen to make sulfur trioxide. The numbers in front give me information about the number of moles of each substance. So 2 moles of sulfur reacts with 3 moles of oxygen to make 2 moles of sulfur trioxide. Notice that the number of moles is just about the number in front, not about these numbers, which are just telling me how many atoms are joined up in a molecule of oxygen. I'm also given information about relative atomic mass, but if I wasn't given that, I would use the periodic table, and I'm given information about the volume of 1 mole of gas, which I won't use unless the question actually involves volume. So in part A, the question is asking for the mass of sulfur. So I want mass. I'm going to write under there grams to tell me about that, and it's sulfur, so I'm going to underline sulfur in my equation. And then it's required to produce 40 grams. I've got mass again, so 40 grams of sulfur trioxide. So the thing that I've been given the information about is the sulfur trioxide, and the thing that I want to find out about is the sulfur. So this is where I need to start my question, because this is the mass in grams that I've been given. So I'm going to use my relationship that number of moles is equal to, and I've done my triangle really badly here, mass in grams divided by the RFM, the mass of 1 mole, the RAM, however you want to say it, it's going to be the mass of 1 mole of the substance, and mass in grams is at the top, number of moles is at the bottom. So I've been given mass in grams, which is that one. I've also been given the mass of 1 mole, the RAM, of sulfur and oxygen, so I can work out the RFM, the formula mass of sulfur trioxide. So I'm going to work that out first. Now I'm ignoring the 2 in front, I'm going to use that in a minute. I'm just going to add up my sulfur, which is 32, plus 3 lots of 16, which comes to 80. So all I've done there is work out the RFM of SO3. Easy so far. Okay, and I haven't got 80 grams, I've got 40 grams, and so my number of moles of sulfur trioxide is going to be 40 divided by 80, mass in grams divided by RFM, and that will give me 0.5 moles. I'm writing down moles every time, and it's moles of SO3. I'm keeping an eye on that. Okay, that's the moles of SO3. I now need to look at the balanced equation, because actually I've been asked to find something out about sulfur and not about SO3. So the numbers in front are 2's both times, which means that for every 2 moles of this, I make 2 moles of this. So that kind of cancels out into a 1-to-1 ratio. So if I've got 0.5 moles, this one, I will also have 0.5 moles of sulfur. So now I've used that equation, I've used the 0.5 moles, I've used that as numbers in front. I'm never going to refer to those numbers again. So what I want to make sure is I don't use that 2 in my RAM of sulfur. I don't times it by 2, because I've already used that 2-to-2 relationship to decide that 0.5 moles of that makes 0.5 moles of that, or is made by 0.5 moles of that. So I've got 0.5 moles of sulfur. The question's asking for mass in grams, so that tells me I need to times number of moles by the relative atomic mass of sulfur, and so my mass in grams of sulfur is going to be 0.5, the number of moles, multiplied by just 32, which gives me 16 grams, and that is my final answer for that question. Okay, Part B. Part B says what volume, so this time I've got a volume of sulfur trioxide gas, so that will be in decimetre cubed, more than likely, and it's produced from 1 decimetre cubed of oxygen gas. So I've been given a volume of the other substance. Now this is really, really easy maths. And the reason it's really, really easy is because 1 mole of gas occupies 24 decimetre cubed. Any gas. So if I look at my equation, oxygen and sulfur trioxide are both gases, because I've been given the volume and I've asked about volumes, that tells me they're gases. So if the equation tells me that 3 moles of oxygen makes 2 moles of sulfur trioxide, well then basically 3 decimetre cubed of oxygen makes 2 decimetre cubed of sulfur trioxide, and the reason for that is because the volume is directly proportional to the number of moles. So that ratio, if I had 3 moles, that would be 24 times 3, it'd be 72 decimetre cubed, would make 48 decimetre cubed. So I've kind of got that relationship. So I can kind of just use a ratio in that case. So I can say that 3 O2s is in a ratio to 2 moles of SO3, which means that 3 decimetre cubed of oxygen is in a ratio to 2 decimetre cubed of sulfur trioxide. All I've done is take that from the equation. I could go through moles, but I don't need to. I'm going to do that in the next question when I have to go from volume into mass. But this time, volume into volume, they're proportional to each other. I don't need to do anything else. So I have 3 to 2 is my ratio, but the question is telling me that I have 1 decimetre cubed of oxygen, and this is what I'm trying to work out. If I had 1 then of oxygen, then how much volume of SO3 would I get? Well, to get from 3 to 1, I have to divide by 3, and in maths, if we're cancelling down, we need to do the same thing to both sides. So 2 divided by 3 will tell me that I get 0.67 decimetres cubed. So all I did was 2 divided by 3. And in fact, if you do it on your calculator, 2 divided by 3 equals, you will get this answer, 0.6666667, and it may say 0.6 recurring. So notice that I've rounded it up to 0.67 decimetres cubed. That's my final answer. I have not put 0.6 recurring because that would suggest too many decimal places and it doesn't work. Okay, the last part is the most challenging, but all I've got to do is go through my moles equations like I did before. So this time it's asking for volume of oxygen, so perhaps I want that in dm cubed like I did before, with grams of sulfur, 16 grams of sulfur. So this is my first piece of information. If I've been given the mass of anything, I can easily turn it into moles using the RAM. So without even looking at the equation, I can do my moles of sulfur. Number of moles of sulfur is mass in grams, which is 16, divided by the mass of 1 mole. The RAM of sulfur, as we used before, is 32. So again, it's 0.5 moles. So now RAM is 32. I'm not using the equation yet. I've done mass in grams divided by the mass of 1 mole to get me, mass in grams divided by the mass of 1 mole in order to get me my number of moles of sulfur. Okay, now it says now volume of oxygen gas. So before I worry about the volume part, I need to check that this is in moles of sulfur. I need to know moles of oxygen. So I need to go back to the equation for this. In my equation, 2 moles of sulfur makes 3 moles of oxygen. So I have 2 of those makes 3 of those. So there are various ways I can do this. My simplest way would be to say that, simplify that down so that my relationship between sulfur and oxygen is 1 to 1.5. So 2 to 3 is the same as going from 1 to 1.5. Every oxygen, the moles, number of moles of oxygen is 1.5 times, because 3 is 1.5 times 2. And so, therefore, I've got 0.5 times 1.5. That tells me how many moles of oxygen I'm going to make. So I'm not very good at maths, so I'm going to do that on my calculator, and it gets me 0.75 moles of O2. And then now I want to be careful. I don't need to use the RFM because I want volume of oxygen gas. Well, I've been told at the top 1 mole of gas occupies 24 decimetre cubed. I don't have 1 mole, I have 0.75 moles. So my volume of O2 is going to be how many moles I've got, 0.75, multiplied by how much 1 mole takes up, 24 dm cubed. So I'm going to pop that in my calculator, and my answer is 18 decimeters cubed. Final answer.